we're going to now look at a few questions dealing with drawing dilations. So we're going to concentrate on drawing dilations of a two-dimensional or three-dimensional object and looking at how we can do that. So here's our first question. Triangle ABC is given. You can see that there on the right. What would the coordinates of the triangle A prime, B prime, C prime be if ABC is dilated by a scale factor of 3? Okay, so remember that for any dilation, if we have a scale factor, I'm going to call it A. If my scale factor is A, if I start with the point xy, my new point is going to be A times x and A times y. So if I look at option A and A prime are exactly the same point because I have A is equal to 1, 1, A prime is equal to 1, 1. So that is no good. So that means that A is not a good answer. My scale factor is 3. If I look at option B, I've got the points 1, 1, 3, 3, and 7, 5 for A, B, and C. A prime is 4, 4. B prime is 6, 6. And C prime is 10, negative 2. What I've done here is I have x plus A, y plus A. That would be what we saw with or what we'll see later on when we do translations. In C, we have A prime is 1, 3. So that and then we got B prime is 3, 9, and C is 7, 15. Well, my y values all get multiplied by A, but my x values, they stay exactly the same. So that one's no good either. So when a scale factor is A, all of our points get multiplied by that scale factor. So 1, 1 should become 3, 3, which I see in D, A prime. B, we had 3, 3. Now we have B prime is 9, 9, which is both parts multiplied by 3. And C was 7, negative 5. C prime is 21, negative 15, which again is A times X and A times Y. So my answer is going to be D. Okay, this question that is asking us to draw a dilation of the following object with a scale factor of 1/3. So that means that all of our pieces get multiplied by a factor of 1/3. So my side lengths right now on this object, I have 3 units up. I have 1, 2. I have 3 units across, and I have 1, 2, 3 units back. So my dilation is going to need to be a 1 by 1 by 1 if I multiply by a scale factor of 1/3, because what I'm doing is 3 times 1/3, 3 times 1/3, and 3 times 1/3. So my new diagram should have a scale factor of, or it should be, dimensions of 1 by 1 by 1. So it's going to look something like this. 1 up, 1 back, 1 across, 1 forward, 1 down, 1 across here, 1 across here, 1 back, and finally 1 up. So we'll notice that in the new shape here, my dimensions for this new shape are we're going to have 1 up, we're going to have 1 across, and we're going to have 1 back. So 3 times 1/3 is equal to 1. 3 times 1/3 is equal to 1. 3 times 1/3 is equal to 1. All of my dimensions are now reduced by a scale factor of 1/3. They've all been made smaller by the scale factor of 1/3. They're 1/3 what they used to be. So dilations have the same angle measures in corresponding angles. We haven't actually measured our angles, but that would be the case here. They also have equal side length ratios. If we did a side length ratio for each of our pieces, our corresponding parts, we'd see that they'd all be exactly the same. We can draw dilations when needed with a ruler, which I did just and a protractor. If you need a protractor. In my case, I didn't because I was on isometric paper. So we can also draw dilations by using grid paper for 2-dimensional or isometric paper for 3-dimensional drawings. And that's what we just did. We looked at one with an isometric paper for 3-dimensional drawings.